This video is on linear regression, or line of best fit. Regression is a function that fits through data the best. Regressions are often used to predict. We'll be focusing on linear regression, which will then turn into what's called the line of best fit, because we want it to fit the data the best. Regression can be done with different functions, so that's why we understand that regression is just a function that fits through the data the best. There are two ways to find linear regression using technology. The first way is using your graphing calculator. So to find linear regression in your graphing calculator, you're going to follow these steps. Step 1, press the stat key, which is capital stat, and then you'll press the number 1. Your screen will turn to a table. So this is step 1. You'll press the stat key. It'll pop up to here. It'll say 1. You'll click edit. Then you're going to go to this screen where it has 3 tables basically, or 3 columns. It says L1, L2, L3. You're going to type the X values into the L1 column, and you'll type in the Y values into the L2 column. Step 2 then says to press the stat key again, and you'll come to this screen, and you're going to go over to the calc section. So you'll press the over button instead of edit. You'll go over to the calc, and you'll press the number 4 for linear regression. And this will be LIN for linear, REG for regression. Now there are 2 linear regression options, but this linear regression option has, in parentheses, AX plus B. So that way it is in slope-intercept form. So A is representing your slope instead of M. And when we do regression, we'll see the letters A, B, C, D. We won't see different letters like M for slope. To see the correlation coefficient, you're actually going to go to the catalog, which is on your graphing calculator. It'll be the second key, literally the button that says second, and then you'll press the button 0. And you're going to select diagnostic on. You'll actually just press the letter D, and it will come to D's, and then you'll scroll down until you see diagnostic on. This will stay on until you reset your calculator. The reason we do this is because when we have done this step, we press linear regression number 4, we get our last screen. It'll say lin reg, and it'll tell you y equals ax plus b, because that is the original function. It'll tell you your a value, which is going to be your slope. It'll tell you your b value, which is the value of your y-intercept. It'll tell you your r squared and r value. Now, this information does not pop up if you do not have the diagnostic on. So on here, we have our a, our b, our r squared, and our r. We don't care about the r squared value for what we're dealing with right now. We can actually write our equation using this information. So our equation is y equals, because we're going to fill it in y equals ax plus b. We're going to fill in the a, we're going to fill in the b. I'm going to use 3 decimal values. So I'm going to have y equals, it's negative 1.257. Then I have to put the letter x. Then I have my b value, which is a positive 6.552. So I'll put plus 6.552. This is the line of best fit. We got this from, again, using our a value is our slope, and our b value is the y value of your y-intercept. Now we're also told the correlation coefficient, which is why we turn our diagnostic on. Draw a little dotted line here. The correlation coefficient remember, the correlation coefficient is only used in linear regression, and it is utilized to determine if the data is a strong or a weak fit with the function is a strong or weak fit to the data, and if it's a positive or a negative correlation as well. So in this case, our correlation coefficient is R equals negative 0.9395. This comes from the R value at the bottom. So R squared is not being used here. We are using the A, the B, and the R for linear regression. Remember, we will not use the R value, the correlation coefficient, for non-linear. So our correlation coefficient of negative 0.9395 tells us some information. This means, so we have which means this, so this function that we created here is a strong negative correlation. It is strong because this number is very close to -1. It's close to 1. 0.9395 is very close to the value of 1. It's negative because the value is negative. So this is close to a -1, which is why it's a strong and negative correlation. And we know that this should be a negative correlation because our slope is negative as well. That's helpful to utilize when we want to make sure that our correlation has the same direction as our slope. Now you can also do the same linear regression in Desmos, and that's what this next piece is going to be about. So to find linear regression in using Desmos graphing, I am going to use the North Carolina testing version. When you get into Desmos, you're going to step 1 is press the plus button right here where it says add item, and then you're going to click table, and a table will pop up and you can type in values. In your table, you're going to type in the table for x sub 1 and y sub 1. Now these can change to x sub 2 if you have multiple tables. So if I wanted to have multiple tables in here, it would have x sub 1, x sub 2, x sub 3. It's so that we can have multiple different functions and different tables on the same Desmos graph. And remember, on a Desmos graph, you can click the color button and it will actually take off the dots so that you don't see it any longer. So once we have our table in there, we're then going to press the regression key, which is going to be at the top left of the screen on where the table is, and it looks like a diagonal line with 4 dots alternating around the line. That's the regression key. And then we're going to select whichever regression is appropriate. Now, the linear regression actually comes first in our drop-down table, and that's what's happening here. I clicked in Desmos, I clicked the plus button, and then I clicked table. I typed in the exact same values from this problem that we had using our graphing calculator. Then I pressed the little line with the 4 dots button up in the top left corner, and it came onto the screen. It says linear regression, and it's in blue. Now if I were to click this drop down menu, I would see multiple different regression options. I wanted to do linear regression for this one so that it would match with the one from the graphing calculator. Now, the linear regression on here will only follow the y equals mx plus b. The graphing calculator had the 2 options, but Desmos will only utilize the 1 option. So Desmos actually, all of the information is given to you, and Desmos graphs the function automatically. So we can see that we are given the equation as is, and you can hopefully see that this regression equation is the same as the regression equation we had from the calculator. So our slope is negative 1.257, and our slope was negative 1.25714. It does give some more values, just like the values in the screen would on the calculator. I only utilize 3 decimal places. The same with the y value or the b value of the y-intercept, which was 6.552380952. And the y value here is 6.55238. So it gives us the same equation. So I'm going to write that as a note. The regression equation is the same as the calculator. The difference is it automatically gives it to you as an equation, so that way you don't have to pick out your a and your b or your slope and your y-intercept value. The calculator also doesn't automatically graph the equation that you have created, but Desmos automatically graphs it onto the data points. And you can also, on Desmos, this magnifying glass in the Desmos screen will actually allow you to fit the data points. So if your data points are very large and you want to make your screen go straight to the data points, if you click the magnifying glass, that's called zoom fit, and it will fit to the data points easier, so that way you can zoom out just a little bit and you can see all of your data points. So on this regression, we also have our statistics, which we have our r squared and our r value. The r value, again, is still what we're looking for. The r value is negative 0.9395. And we have negative 0.9395. That is the same r value from the calculator. So I'm going to make another note. The correlation coefficient, which again is r, is the same as the calculator. So this information was the same as the calculator. So our a value, or our slope, was the same. Our b value was the same. And our correlation coefficient was the same. So all of these values were the same, so we can utilize Desmos for maybe a quicker version of this, and also so that it automatically graphs the function for us. Now the calculator can graph the function, you just have to do more commands to the calculator. Desmos does it for you because it's already commanded to do so. Now the last thing I want to talk about is this section here where it says residuals E sub 1 plot. What this does is Desmos will allow you to plot the residuals to determine which regression is more appropriate or most appropriate. Now, we know that our R value, because it's linear, is here. However, if we were to plot the residuals, we would be able to use the residual values to determine if the linear regression is in fact the best regression to use. It could be that a quadratic regression would be better, or an exponential regression would be better. It all depends on the residuals. So the most common regressions used are linear, exponential, quadratic, cubic, and logarithmic. So this one was linear regression, but we would follow the exact same steps to do exponential regression, quadratic regression, cubic regression, and logarithmic regression. It's just in the drop-down menu. And again, the residuals, when we plot the residuals, it'll tell us into a table. We'll get the numbers of the residuals in the table along with your x and y values. And it will also plot the residuals on the graph. And the residuals, whichever residuals are closer to the value of 0, that will actually tell you which regression would be the better fit.